Good morning and welcome to the third of three videos on section 1.4 in your Precalculus textbook. All right, in this video, we're going to begin with example number 8. Now, example number 8 says, you work in the marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. So, yes. So here's your can. All right. This distance here is the height, and this distance here is the radius. And I know that the ratio of the height to the radius is 4. So what that means is that 4r equals h, or that r equals h divided by 4. Now, the question says, write the volume of the can as a function of the radius r. Well, the first thing that you have to realize is that the volume rather of a cylinder is actually equal to pi times the radius squared times the height. Okay, this is just the volume of a cylinder, right? Something that you should have learned in probably your geometry classes. Now, if you're asked to write the volume of the can as a function of r, then in this case, we write as pi times r squared, and then we have to express h as a function of r. Well, we know that h is equal to 4r, and so I write this as 4r, and that gives me a grand total of, I'll put the constants first, so 4 pi times r cubed, right? Because r squared times r is r cubed. And so that represents the volume of the can as a function of the radius. Now, if you're asked to write the volume of the can as a function of the height, we just don't do that. We do this. Volume in terms of h, all right, so V of h is equal to pi times, now, r is equal to h over 4. And so I'm going to plug in here h over 4 quantity squared times h, okay? And if I do some math here, and I'll do this in 2 steps, h over 4 squared is going to be h squared over 16, right? Because h times h is h squared, and 4 times 4 is 16 times h, okay? And so that's going to give me, and I can do this in a couple of different ways, but essentially pi times h cubed divided by 16. And so that's the volume of the can as a function of the height. Okay, easy peasy. All right, notice there's a little bit of arithmetic in here, but not much. All right, and there's no numerical answer because I'm not giving you a value of radius or height. Okay. So let's look at example number 9, shall we? It says a batter hits a baseball at a point 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function f of x equals negative 0.0032 x squared plus x plus 3. Now, those of you who took a physics class in high school may recognize 32 feet per second squared as the acceleration of gravity. So that's where this number comes from, and it's negative because gravity pulls the ball back downward. 3 represents the starting height, right? Because we started at a point 3 feet above the ground. So So f of x is the height of the baseball in feet. X is the horizontal distance from home plate in feet. And the question is, will the baseball clear a 10-foot fence located 300 feet from home plate? So, in order to do this calculation, we are going to represent this as f of the value. Whoops! Wow, 300. All right. X is the horizontal distance from home plate. So 300 feet from home plate. That's going to equal negative 0.0032 times 300 plus 300 plus 3. Now, if you do a little bit of arithmetic here, all right, get out your handy dandy four-function calculator and start plugging in some numbers. You get that, let's see, negative 0.0032 times 300 is negative 0.96. No, that can't be right. Oh, you know what? I forgot the squared. All right, so it's 300 squared times negative 0.0032, and that gives me negative 288. Okay, so negative 288 plus 300. Gabby, knock it off. Plus 300 plus 3. And if you do the arithmetic here, negative 288 plus 300 is 12, plus 3 is 15. Okay, so will the baseball clear a 10-foot fence located 300 feet from home plate? Survey says absolutely. It's 15 feet above the ground. Therefore, it's 5 feet above the top of the wall. So yes. Okay, yes, indeed. Okay. Now, example number 10 is, this looks like it's really complex, okay? But in reality, it's not. All right, let's read this carefully together. The number V in thousands of alternative fueled vehicles in the United States increased in a linear pattern from 2003 to 2005, and then increased in a different linear pattern from 2006 through 2009. These two patterns can be approximated by the function v of t equals 29.05 t plus 447.7 at a value of t of between 3 and 5. And it increased at v of t equals 65.50 t plus 241.9 at a value of t is between 6 and 9, where t represents the year, with a t of 3 corresponding to 2003, and therefore t of 9 representing 2009. And so use this function to approximate the number of alternative fueled vehicles for each year from 2003 through 2009. Now, this does involve a lot of arithmetic, but it's really not as troublesome as you might think. So let's look. So here are the equations from the previous slide. All right, we're going to use each of these equations. So for 2003, we're going to obviously use the first equation, and so that's going to be v of 3 equals 29.05 times 3 plus 447.7. And if you do the arithmetic here, you come up with 534 0.9. All right. So because V is in thousands, this is 534,900 cars. Same thing for 2004. All right. And in this case, V of 4 equals, and same thing, except we're going to put a 4 here. And that's going to give us 563.9. All right. In 2005, it's V of 5, and we're going to use the same equation, just plugging in a 5 instead of the 3 or the 4. And that's going to give us a grand total of 593,000.0. Okay. Now, for 2006, we start with the next equation. And so now V of 6 is going to equal 65.50 times 6 plus 241.9. And I'm sorry about the sloppiness. I'm trying to write with a mouse. It's not easy. But if you do the math, you end up with 634,900. In 2007, it's V of 7. Same equation as here, except that we plug in a 7 instead of a 6. That gives us 700,400. 2008, V of 8. We plug in the 8 instead of the 6 or the 7, and that's going to give us 765,000. And I'm just reading these numbers right out of the textbook. But please get out your magic number boxes and make sure that you can get these answers with your calculations. All right. V of 9 is 65.50 times 9 plus 241.9 equals, and that's going to give us 831,400 vehicles. All right, so that's example number 10. Okay. All right, and again, in this case, it's just a lot of algebra and a lot of arithmetic. Not really algebra, just arithmetic. Okay, now, this course is entitled Precalculus, okay? But I'm going to introduce here a function that is exceptionally important in the basic idea of the calculus, all right? And so one of the basic definitions in calculus employs a ratio called a difference quotient, all right? And what a difference quotient is as long as this value h is not equal to 0, all right? But generally speaking, it's a very small term. We're talking about the difference between two numbers that are y values that are very close. If y is approaching a very tiny number, it's approaching 0, but not actually at 0. What this does is it gives us a ratio, a relationship that allows us to calculate what we call a limit. Now, some of you may have heard that term before. Hopefully, you've done limits in high school. If not, it's not a big deal. We will cover it. But this is what the essential purpose of this is. All right, and so the equation is f of the quantity x plus h, where h is a really small number, minus f of x over h, all right, when the value of h is not equal to 0. So how do we put this into action? Well, we want to find the difference quotient for the function f of x equals x squared minus 4x plus 7. All right, so we're going to write down the difference quotient. It's f of x plus h minus f of x all over h. All right, that's the difference quotient. So if f of x is equal to x squared minus 4x plus 7, then f of x plus h is going to equal x plus, and I'm going to put this in big brackets, x plus h squared. Sorry, I really am sorry about this. Minus 4 times x plus h plus 7. Okay, and that's f of x plus h minus x, x squared minus 4x plus 7. All divided by h. Oh, for the love of God. Okay, now the value x plus h squared, all right, this is going to be equal to x squared plus x times h plus x times h is 2x times h plus h times h is h squared minus 4x minus 4h, right, because the minus 4 times each of those, plus 7. Then minus, now I'm going to distribute the negative here, so minus x squared plus 4x, right, because negative times negative is positive, minus 7. Again, all over h. Whoops, that was an ugly h. Now, I'm going to change the color of the pen so this becomes a little bit more clear. I'm going to immediately get rid of the x squared and the negative x squared, the negative 4x and the positive 4x, the positive 7 and the negative 7. So they all go bye-bye. All right. Then I'm going to divide everything in here by h, right? If I divide that, the h goes away, the squared goes away, the h goes away, and I'm left here with, go back to my red pen, 2x plus h. All right. And I'm missing, I think that should be it. Oh no, minus 4, right? Because there's a 4 here. We get rid of the h's. All right. And so that's sloppy, but it says 2x plus h minus 4. All right. And this, of course, is when the value of h is not equal to 0. Okay, so that is the difference quotient, 2x plus h minus 4, where h is a really small number. We'll come back to this when we get to limits, but this is a function, and therefore I kind of wanted to introduce it here. All right, now, last but not least, your homework. For homework due before our next class, I'd like you to do the questions at the end of section 1.4, which begin on page 44 in your textbook. I would like you to do questions 1 through 87, but odd numbers only. Okay, odd numbers only. And I would like you to write your answers on a piece of paper. All right, it can be any kind of paper, loose leaf paper, spiral notebook, whatever it is, a piece of computer paper, whatever it happens to be. And then I want you to take a picture of each of your pages and submit it to my email. All right, grapp, grapp at siena.edu. All right, please do so before the beginning of our next class. Now, again, odd numbers only. So it says, oh, 1 to 87. Oh my God, right? But but you only have to go. You only have to do the odd numbers. Okay. And in our Zoom session at the beginning of Thursday's class, we'll go through any problems that you had difficulties with. Now, how do you know you had difficulties? Well, at the end of the book, there is an answer key. All right. And so you can check your answers. All right. And then we'll talk about any questions that you may have had some difficulty with. All right, boys and girls, I hope that was helpful, and I hope that you learned something.